video, I'm going to talk about the second example of finding the least common multiple of from these two trinomials right over here. It is 3z to the third power minus 2z squared minus 9z, and 7z to the fourth power plus 21z to the third power plus 14z squared. And the way to find the common multiple is that we simplified, we split this expression into some specific numbers, and then we can multiply the things together that they don't contain in order to find the least common multiple. So let's do it. For 3z to the third power minus 6z squared minus 9z, we can simplify it with the greatest common division, which is going to be 3z multiplied by. So if you divide 3z to the third power into 3z, it will going to be equal to z squared. And minus 6z squared divided by 3z will just going to be negative 2z. And negative 9z divided by 3z will just going to be negative 3. And for this expression right over here, we can also simplify it. It will going to be equal to the greatest common division is going to be 7z squared and multiply by, so a little bit weird, it's multiply by, so 7z to the fourth power divided by 7z squared will just going to be z squared, and 21 times z to the third power divided by 7z squared will just going to be positive 3z, and positive 14z squared divided by 7z squared will just going to be positive 2. And we can simplify these expressions really, and we're going to be 3 times z. And since we know that this expression right over here is quadratic equation that after we saw the greatest exponent is equal to 2, we can simplify the binomial. So if you simplify the binomial, it will going to be equal to z times z, it will make z squared. And if you multiply the two numbers, it will going to give us negative 3. And if we add together, it will going to give us negative 2z. And I think it will going to be equal to, let's see, I think we're going to be negative 1 and positive 1. It is right. And this was our kind of steps of making this expression into binomials. The reason why we're doing it is because we want to split these numbers as many as we can in order to multiply together. And for 7z squared, this term right over here, we can also simplify it into binomial, and I need to write 7z squared multiplied by, and we can just change into binomial since we know that this is a quadratic equation. So we're going to be z times z, and it's something if you multiply together, it will going to give us 2, and if we add together, it will going to be 3z. And if you look at those numbers, so it will going to be equal to positive 2 and a positive 1. So let's look at this. Let's compare these two expressions. The common thing is that they both contain z plus 1 term, so we just have to write z plus 1. We don't have to multiply two of them, both of them, because if you multiply two of them, we won't be able to make the least common multiple. So it will going to be equal to, we can multiply z plus 1 term, so z plus 1. And for z minus 3 and z plus 2, they don't both contain it, so we can just write it z minus 3 times z plus 2. And this is kind of interesting also that 7z squared and also 3z, they both contain z, but this term right over here doesn't contain z squared, so we need to write z squared. And for 3 and 7, the least common multiple of it is 21. So we can figure out that this expression right over here, it is our least common multiple for this first expression. In the next video, I'm going to talk about the last example of finding the least common multiple from these two trinomials.